So in this problem, we need to resolve the given rational fraction into partial fraction. So let us begin. So here we have 1 over x squared plus 2 multiplied to x plus 1. So there are two factors involved here in the denominator. One of the factor is x plus 1 and the other one is a quadratic factor, which is x squared plus 2. So this can be resolved into two partial fractions. The first one being a over x plus 1 plus the second partial fraction. Now since x squared plus 2 is a quadratic fraction, so its numerator portion will be bx plus c divided by x squared plus 2. So this is how we can resolve the given rational fraction into its constituent partial fraction. Our goal will be to determine the value of a, b and c. So we're going to label this as number 1. Okay, so the first task will be, we'll take equation number 1 and multiply throughout with the denominator of the expression on the left hand side, which is x squared plus 2 multiplied to x plus 1. So that's going to give us 1 equals to x squared plus 2 times a, plus we have x plus 1 multiplied to bx plus c. Okay, so let's label this as number 2. Then in the next step, what we'll do, we'll take equation number 2 and we're going to simplify the expression on the right hand side and combine all the like terms. So that's going to give us x squared multiplied to a plus b plus x times b plus c plus 2a plus c. So this will be equation number 3. But what we'll do, we're going to rewrite the term on the left hand side as 0 times x squared, because there is no term containing x squared. Then we also have no term containing x, so we can rewrite it as 0 times x plus the constant term 1. So this is done so that we can compare both sides. So let's label this as number 3. So if we compare both sides, we will get a plus b equals to 0. All we are doing is equating the coefficient of x squared on both sides. Similarly, we can compare the coefficient of x on both sides. So that's going to give us b plus c equals to 0. And then we're comparing the constant terms, 2 plus c. So this will be equals to 1. So using this, we can easily find these three equations. We can find out a, b and c because we have 3 unknowns and we have 3 equations. So we can easily find out the value of a, b and c. However, the reason why I used equation number 2 because here we can find out at least one value using the technique. So let's say whenever we choose, because we see here that there is a factor x plus 1 multiplied to the second term bx plus c. So if we let x plus 1 equals to 0, meaning if we take x equals to -1, then the entire second term will go to 0 and we'll be only left with the first term, which has the constant a, and we can find out the value of a quickly. Then let's do that. Then our equation number 2 will give us 1 equals to, so we have -1 squared plus 2. This is multiplied to a, and the entire second term goes to 0. So here we can find out the value of a. So a comes out to be 1/3. Because -1 squared is 1, 1 plus 2 is 3. Okay, now that we have the value of a, let's try to find out the value of b and c. So from this particular equation, so here we can write b as equals to -a. We have already obtained the value of a, so b is going to be equals to -1/3. So we can also find out the value of c either using this equation or this equation. So let's use equation number 2. That will be simpler. So b plus c equals to 0. So that means c must be equals to -b. And since b is -1/3, so c will be simply +1/3. So now we have found out the value of a. So a is +1/3, b is -1/3, and c is +1/3. So we have obtained the value of a, b and c. All we have to do now is substitute the value of a, b and c in number 1. So we should now get, we have 1 over x squared plus 2 multiplied to x plus 1. So this will be equals to, so we have chosen a over x plus 1. So a value is 1/3. So we have 1/3 over x plus 1 plus bx over c. So we have -1/3 x plus c divided by x squared plus 2. So we're going to rewrite this. Thus, we get the final value. So we have 1 over x squared plus 2 multiplied to x plus 1. So this will be equals to 1 over 3 times x plus 1. Then we have negative 1 over negative x minus 1 divided by 3 times x squared plus 2. Right. So this is how we have successfully decomposed, or we can say resolved, the given rational fraction into its constituent partial fractions. And if you want, what you can do is you can cross check by combining the two partial fraction, and this should give you the rational fraction.